Hello, this is a demonstration video for SIT 331, a task 2.1. So, in this task, we were required to make a robot system which can move on a specific grid. So, firstly, let's start with the code. So, here, firstly, we have defined the robot class which has three which has some properties like it has a public int get set property. This one basically this is the this property is this line defines the get property for x coordinate of robot, and similarly this one is for y coordinate public int y get set. So, and then there is a direction property for setting up the direction of robot like north, south, west, east. And then these two properties last x and last y, these are used to show the previous location of robot like previous coordinate. If it is on 1 comma 1 right now, and before any addition or any updation it was at 1 comma 0, then this will store that particular values of x and y. Then there is a flag called is placed, which is defined by the bool type. So this is for checking if the robot is placed on the grid or not. Then there is the first function of this code, which is place place function. So this method is used to place the robot on a grid. So it accepts three parameters: x coordinate, y coordinate, and direction. So firstly, it checks that the position is valid and if the direction is valid. If both are valid, it updates the robot position and direction, sets its place flag to true, and prints a message indicating the robot's position robot placed at this in this direction. Like if we set the robot placed at 1 comma 0 and facing the direction north. If there is an error, it will show invalid placement, please try again. Then there is a function named as the second function for turning the robot. This is turn left. So similarly, this function also checks whether the robot is placed or not, because without placing the robot, no, no command can work. Like no, it cannot move, it cannot turn left, it cannot turn right. So firstly we need to place the robot. So this is the left function. So it checks the robot if it is placed, and if it is valid, then it updates the direction on the current direction. For example, if the robot is facing north and turns left, then it will face west. And if the robot has not been placed, it will show error message that robot has not been placed, please use the place command first. So then there is another function for turning the robot to right. This will work same. Firstly it will check if the robot is placed. Then similarly, if the robot is in north, then to it will face the robot to its right, which is east, in east direction. So similarly the same error will be placed if there is any issue with turning right. Then there is the main function of this code, which is the move function. So the move function helps in checking, uh, it helps to stimulate the robot to move forward, and it checks if the robot is placed on the grid. Firstly, every function will check if the robot is placed on the grid or not. Then it calculates the new position uh, that based on the current direction. For example, if the robot is facing north and moves forward, its y coordinate will increase by 1. If it is in east, its x coordinate will increase. If it is in south, then y coordinate will decrease. And if it is in west, then the x coordinate will decrease. So, if the new position is valid, it updates the robot position and prints message indicating robot's new position. Like here, if it is a valid position, then the robot will set that robot move from the last, it will show the last position of the robot, like if it is on 1 comma 0 and it is moving in the north direction, then it will show 1 comma 1, and it will say robot move from 1 comma 0 to 1 comma 1. And if it is not happening, then it will show an error that robot, if the robot movement will lead to falling it off the grid, means if the grid is of 6 by 6 and a movement will uh, say, if the robot is moving and there is a such movement that it will cross the grid, then it will not move, and it will say that this is an invalid move. This may lead to falling the robot out of the grid. Then there are two functions for checking the valid position. So if this function checks that the given position x comma y on a grid, it returns true if the position is within the bounds, like it is in the size of map and it's a valid position. Like x and y coordinate both are greater than 0 and equal to 0 and less than the side of grid, which is the size of map basically. And it will return false otherwise if the condition is not matching. Then there is a function for checking the valid direction. This is for if the user types the direction as NOTH, not NORTH, north, then it will check for that there are four directions basically: north, east, south, west. If there is a grammatical error in the word, in the string of direction, then this function will work to check that particular direction. So then there is a class map, which basically has a static method to set. Basically there is a variable named as size, which has a get set property, and there is also a function named as set map size. So this function takes an integer parameter, like we set the size of a map by giving it some size, like from 2 to 100, between 2 and 100. So firstly it will check if the size is greater than 2 or equal to 2 and size is between 2 and 100. If the size is valid, it will assign the particular size to the variable size, and it will print the map is bounded to this by this coordinate. Like if it is 6, then it will say the map size is set to 6 by 6 square. So it is a squared grid for the map. And if the value in the map is not a particular value, if it is 0, 1 or beyond 100, then it will say invalid map size and say please enter a size between 2 by 2 and 100 by 100. So then there is a main function of the code. Firstly, this starts by asking the user to enter the size of the map. Like here it will ask for the size of the map, and then it keep asking the size until the user uh, enters a valid size. If he or she does not enter a valid size, this will remain asking. This will keep on repeatedly asking the size of the map. Then it will set the map size. Then there is then it creates the instance of robot class named as map here. So moon robot as a new instance of robot class. Then uh, firstly it will ask the user to enter a command. So when the user will run this code, he or she will have to first place the robot. Like if the command is place, then it has two arguments, x, y and direction, and calls the place command of the moon instance. If the command is left, right or move, it calls the respective method for moon instance. If the command is invalid, it prints the error message. And this loop will continue indefinitely until the program will terminate. So now let's go to the execution part of this code. So Now let's run this code. There. Now see, it is asking for map size, so let's put the map size as 7. Now the map is set by 7 squares. Then it will ask for which command you want to perform. So if firstly I have to place the robot. If in case I don't place the robot and I try to move the robot to, then it will say please place the robot first, use a place command. This is same for left and right command also, which you can see here. Left command, it is not placed. Right command is not placed. So firstly we have to place the robot. So like place, then specify the x and y coordinate, x1 comma 1, then the direction, which is north. Okay, so I have placed, will show the robot placed at this coordinate facing north. Now after this we can use this command move left and right. So now let's move the robot. Move command. So the y coordinate is changing as it is facing the north, so it will move in the side of y coordinate. So again we will move this till it reaches the boundary of the grid. So now see, it moved from to till 6th position, like from 0 to 6. I started it from 1 comma 1 and it is moving till 6 and not 7, because I have stated that the robot can move from uh, x coordinate if it is valid position, like is always less than the map size for x and y coordinate both. Yes. It will not go to 7, it will remain inside the grid only, it will not go to the boundary. So this will help the robot to not to move outside the boundary of the robot. So if we turn the robot to the right direction, so it is showing robot turn right. Now I will move this. So now you can see, if uh, currently the robot is in no direction, and when I move this, turn this to right, so it turned 90 degrees right. So the right of north is our east basically. So it is going on the east direction, and in east direction it is updating the value of x coordinate, like from 1. Here the x coordinate, the previous x coordinate was 1 and now the x coordinate is 2. Now if we move further, it will update the x coordinate and it will go to 6 and 6. So if you further move this, it will say the robot will fall beyond the map. And similarly this is same for the left also. And this was my code, this was my demonstration of this code. Thank you.